In this video, we will give a brief review of our integration techniques that we've talked about up till this point, and then do an example. So our methods for evaluating integrals that we've talked about up until this point, there's 4 of them. So one of the 4 is by using basic antiderivative rules. Things like the reverse power rule, or if I have the antiderivative of e to the 5x. This is something that we can do with a basic rule. So another technique that we've learned is U-Substitution. So U-Substitution, we can use that to evaluate integrals. The third method I'm going to list is what this section 7.1 is all about, integration by parts. Integration by parts. And there's one other main method, which is to use areas. But this method, the areas method, only applies for definite integrals, because definite integrals represent areas. Indefinite integrals just mean the general antiderivative. So this is only for definite integrals with shapes that I can actually find the area of using geometry. So those would be for linear or circular path graphs, because I need to create shapes like semicircles or quarter circles or triangles or rectangles. So one of the big goals for our class is when we're given an example of an integral, and we're about to look at one, when we're given an example of an integral like this, determining which method to use, which method is best. And that is something that will develop with experience. It's something that we've started to talk bit by bit about as we've gone through more examples in this section. And it's something that we've also talked on back in U-Sub. In U-Sub, we did an example where I showed that, oh, not everything is U-Subable. There's some integrals that don't actually require U-Sub. Similarly, there's some integrals that don't require integration by parts. Okay, so that review done, let's look at this example. So let me scroll it down here. Okay, so I zoomed it out a little bit so I have some more room to look at. But what I want you to do first is to pause this video. This time for 4 minutes. I'm going to give you more time for this. To try this question. I'm not going to give you any advice. Just to try this question. 4, 3, 2, 1, pause the video. This may not be enough time to finish the whole problem, and that is absolutely okay. I want you to believe that the time that you put in during these pauses to try questions is helpful. This is time that you're spending practicing things. Even if you struggle and don't fully figure it out, or if you're struggling on how to begin, believe that that time is going to be helpful. And at the very least, if you're stuck, I want you to try different things. So if you're stuck on how to begin, maybe try a U-Sub. Or if you're stuck on how to begin, try an integration by parts, even if you're not sure what the best one may be. All right, so hopefully you've paused it for 4 minutes to try this. If not, really go ahead and do that. That is super important. Okay, but let's talk about it together. So let's just try something. Let's try integration by parts. Let's say we were looking at this problem, not totally sure what to do, which happens to me even. Let's try integration by parts. So I need to pick something for u and to pick something for dv. And let's say I don't know what to pick. Maybe I'll let u be the e part, e to the negative t to the 4th. And that means dv would be the other stuff, t to the 7 dt. So now I could write du and v. The derivative of e to the negative t to the 4th requires chain rule. I'll get e to this stuff, e to the negative t to the 4th, but then I have to multiply by the derivative of the exponent, which is negative 4t cubed, and I have to make sure I write a dt. So that's the derivative. Okay, and for v, the antiderivative of t to the 7, I would write t to the 8 over 8. So now when I plug it into my integration by parts formula, we'll get uv, which is going to be t to the 8 times e to the negative t to the 4 over 8 minus the integral of v du. So that would be t to the 8 over 8 du, which is, let me put the negative 4t cubed in front, times e to the negative t to the 4th dt. Okay, so now let's analyze this integral and see if it's easier than the one I started with. So if I look at this integral, I have this t cubed, going to multiply the t to the 8, and that gives me a t to the 11. There's a t to the 11, and there's still the exponential thing. So that actually looks harder than the one that I started with, because I've actually made the power of t bigger. This is harder than the original. I've actually made the power of t bigger. Okay, so I'll put a sad face, kind of an angry looking face even there. Okay, one of the ways I could have spotted that is, when I picked u, to notice that its derivative was more complicated than what u was. Because the derivative, this du term, is going to go in this new integral. So typically we want that to be simpler than what u was originally. Alright, so this integration by parts didn't work, so maybe we can choose a different u and dv. Different u and dv. Just because this integration by parts didn't work doesn't necessarily mean that integration by parts is wrong. Maybe there's just a better choice for u and dv. So let's try a different choice. Okay, so what if I let u be the other thing, the t to the 7, and then I let dv be the e to the negative t to the 4th dt. Okay, and then I would need to think about what du is and what v is. So I'm going to think about v first for this one, before I even do du, because I noticed something. I am actually confused here for a reason. I need to do the antiderivative of e to the negative t to the 4th. And this is hard. This is hard to integrate. Okay, so I'm going to put a sad face next to this. It actually turns out that the antiderivative of e to the negative t to the 4th is actually impossible to do using the functions that we know. But that's a side fact. For our purposes, it's enough to recognize that it's hard to integrate. We could try it, but this one's hard to integrate. And that's a roadblock. That's suggesting that, okay, at the very least, this is not a good choice for u and dv. Okay, so we've tried integration by parts actually in two different ways, and neither seem to be helpful. And I think we've tried the two most natural choices for u and dv, so maybe integration by parts just isn't the way to go. Okay, so then I might go back to my problem and think about, okay, is there a different technique that we could use? So what if we try U-sub on this? Let's zoom it out a little bit so I can still see it. But what if we try a U-sub? So what if we now try... What if we try U-sub instead? So if we try U-sub, we'll have to pick something for u. So maybe I'll try the exponent. So a lot of the times in these U-sub questions that have e to a power, often letting u be that power tends to be helpful. Okay, then du would be negative 4t cubed, and then I got to write the dt. And now let's isolate dt. And if we isolate it, we'll get du over negative 4t cubed equals dt. So let's take that and now let's plug into our integral. Okay, let me zoom it out a little bit more so I can still look at the original. So if we start to plug in to the original integral, we'll get integral of t to the 7, e to the u, and then I plug in for dt, which was du over negative 4t cubed. Okay, now I'm going to zoom it into this because I've plugged in. Let's zoom it in. So it's a little bit easier to write. Alrighty, so this is something I can simplify. This negative 4 I can pull to the front, and it becomes a negative 1/4 in front. T to the 7 divided by t to the 3rd is t to the 4th. And then I have e to the u du. So when I did this u-sub, it didn't cancel away the t's perfectly. But sometimes that happens when we do U-subs, where the t doesn't cancel away perfectly. And one of the things that we can try is to go back to the U-sub. So go back to here and see if we can use it again to plug in for those lingering t's. So I see this t to the fourth is lingering. So I'm going to go back to this U-sub. So I'm going to write this down. Let's use u equals negative t to the fourth again. But I am going to somehow need to know what t to the fourth is. And if I just move the negative sign over, we get negative u is equal to t to the fourth. So I get to replace t to the fourth with negative u, because that's what it's equal to. Okay, so this equals negative 1/4 integral t to the fourth is negative u. And then I have times e to the u du. And I can pull the negative out in front and get 1/4 times the integral of u e to the u du. Okay, so I'm still not done. Like, this is not an antiderivative that I know how to do in my head, but it's a lot simpler than what I started with. So that tells me that this is probably a good thing. So now I have to think again about, well, what do I do to proceed with this integral? Well, we've actually looked at maybe 2 examples, or maybe even 3 examples in this section that have looked like this. So what was the method that we used to evaluate them? It was integration by parts. Okay, so it seems like U-sub was helping, and now I need to use integration by parts on top of that. So that can happen. Sometimes I use more than one method in the same problem. Okay, so I'm going to have to pick my u and my dv. But in this problem, there's already a u, so it would be confusing if I said u. So I'm going to call this thing w instead of u in my integration by parts. And I'm going to let w be the u, because that has a very simple derivative, and dv be the other stuff, the e to the u du. Okay, then dw, the derivative of u is 1, but I have to make sure that I write a d, not a dx. My variable's a u here, so du. And what would v be? Antiderivative e to the u is just e to the u. Alrighty, so now we are ready to plug in. So this equals 1/4. Let's put a big bracket, and then I got to start to plug in my integration by parts stuff. So I'll get, instead of uv, it's wv, so that is u times e to the u, minus the integral of v dw, which is e to the u times 1 du, and close that bracket. Okay, and now I know integration by parts is helpful here because I ended up with the integral of e to the u, and that we know how to do. Or at the very least, it's easier than the integral I had before this. And that's the goal of integration by parts, to turn the integral that I had before this to something that is easier to evaluate. All right, so we have 1/4 bracket u e to the u, and then minus antiderivative e to the u is just e to the u. And then I need to put my plus c, but so what I'm going to do is I'm actually going to close the bracket and put the plus c way at the end. So why is that okay to do? So for the time being, I'm going to erase this. What would have happened if I had put the plus c inside? If I put the plus c inside, next I would need to distribute this 1 to the 1/4 to each of these terms. But when I distribute it to the plus c, we would end up with a 1/4 c at the end. But the 1/4 c is just a constant. So you could just name this. We could have just called this a constant. We could have just named this like c if we wanted to. So even if we did this, at the end of the whole thing, we would have a constant, and I could have just named that c. So instead, just for simplicity, I'm going to say, okay, I know I'm going to get that constant even after I distribute the 1/4. So I might as well just close the bracket and then put that constant outside and just call it c from the get-go. Okay, I'm almost done. When we did a u-sub, remember, we need to now sub back in. Sub back in. What was u equal to? So we have 1/4 times u was negative t to the 4th. I have negative t to the 4th times e to the negative t to the 4th minus e to the negative t to the 4th. Close that bracket, plus c, and that is my answer. So just to recap, in this example, we weren't sure what method to use initially. We weren't sure what method to use. I tried integration by parts a couple ways. It didn't work, but we didn't give up. We persevered. Then we tried U-sub, and it was helpful, and ultimately it ended up giving us an answer. And that's the way it goes. This is part of the way that we build that experience, so that when we see new problems, we have this experience to leverage. And hopefully we're able to find that best method more quickly. Alrighty, so in terms of our goals for this section, we have just finished our fourth goal, reviewing our methods for doing antiderivatives, and then we did an example.